Alright friends, welcome back. In this video I'd like to take a quick day 2 for section 3.1 from your textbook and continue to talk about quadratics. So if you had not had an opportunity to watch the 3.1 day 1 video, definitely would encourage you to go ahead and give that one a watch before continuing with this one. So in this video specifically I'd like to go ahead and not introduce anything new conceptually, but I'd like to go ahead and discuss a couple of the different examples that you guys will be up against when you do your homework assignments and then quizzes and tests coming up. So as you go through here, basically I'm going to go ahead and do the first one from each one of these little example sets, and then we'll kind of flash the second one up on the screen, which I already have done just for the sake of time in the video. Okay, so the directions here in example 1, it says write an equation for the parabola in standard form. So basically here I'm giving you the picture of the parabola and you have to come up with the function formula for that. Okay, and so in order to do that, again, they did ask us for standard form, and we have to just remember from the last video what standard form looks like. And so the standard form of the function formula for a quadratic will look like this: y is equal to some number a times x minus some number h squared, and then plus some number k. Okay, in which case we know that the three most important numbers of this form are basically your h and k, and then also you have this number a that's in front here. Okay, once we've found values for each one of those three variables, then we will have answered the question. All right. And so the basic question becomes, how can I get those three numbers if all I have is this picture? Well, we just have to go ahead and look closely at the picture and make sure we understand what it is we're actually looking at. So we gave you a picture of a parabola here, and you'll notice that the point that is the very lowest point here, that has coordinates in this picture. It's -2, -1. And if you remember from the previous video, the vertex is always the point that is the lowest point in your parabola if it opens up, or the highest point in your parabola if it opens down. But here what we're basically saying is that the coordinates of the vertex are here, which are -2 and -1. Okay. Over in the actual function formula, remember that that is what the job of h and k are. They are the coordinates themselves of the vertex. That's why some folks call the form that you're looking at here vertex form. And so what I'm going to do to start us off here is I'm just basically going to go ahead and plug those numbers in, and we're going to go ahead and continue here. So that is going to be -2 for the x coordinate, that's what h is, and then -1 for the y coordinate, that of course is what k is. Okay, and then just so that we're taking this slow one step at a time, I'm just going to go ahead and write out the rest of the function formula just exactly the way that it looks, and then we'll go ahead and clean up these sign changes here. Okay, you have a double negative there, so we know that that changes to plus, so we'll say y is equal to a times the quantity x plus 2 squared, and then we have a plus -1. We know that that changes to -1. Okay, and so now here at this point we have still the unknown a. We still don't know exactly what value that is, but you'll notice if you look back at the picture that I gave you another point with another set of coordinates here. And so that is going to be this point right here, 0, 3, corresponding to, of course, this point on the parabola. Okay. Now, here's the thing about these coordinate points is that these are always going to represent the input x as the x coordinate and the output y as the y coordinate. So when you're looking at something like -2, -1, or 0, 3, that basically means that we plugged in a -2 into this machine and got out a -1. And also it means that we plugged in a 0 into this machine and we got out a +3. So these are basically just input-output pairs, and so what that means is we can go back to our function formula and remember that x and y in the formula basically represent the input and the output. And so what that allows us to do is take a look at this green point right here, 0, 3, as a value for x or y that we could plug in and figure out what that value a is going to be. Okay, so that's going to be what I'm going to follow up with here. I'm going to go ahead and plug in place of y and x just the y and x coordinates for my point. So playing the role of y is 3 and playing the role of x is 0. Just be sure that you're plugging in the appropriate point for x and for y. Okay. And so that's going to be equal to a times the quantity 0 plus 2 squared minus 1. And then if you look at our equation in its current form, this has all of the numbers plugged in except for that value of a, which we can now just go ahead and solve like this is an equation. Okay? And so continuing here, I have 0 plus 2. That's going to make 2. If I were to square 2, I would end up with 4. So on the right-hand side, this is going to simplify down to 4a minus 1 is equal to 3. And of course, our goal from here on in is to go ahead and solve for that value a. Now, that's just a two-step equation. I'm not going to show the rest of the steps in order to go ahead and get that a isolated. I will just go ahead and share with you that what a's value is going to have to be if you do your inverse operations there is just simply a value of positive 1. Okay? And so we said in the very beginning of the problem that we would be finished if we were able to come up with a value for a and then also a value for h and k in this function formula, and I definitely think that we have accomplished that goal at this time. So I'm going to go ahead and write out my final answer here, which is going to be that function formula with my values plugged in. So that's going to look like y is equal to, playing the role of a, of course, again, is just 1, but you guys all remember that if you have a 1 out in front, there's no point in writing it since it's basically just 1 times, okay? So I'm just going to go ahead and write this as x plus 2 squared and then minus 1, okay? And that will be my final result for part A. Okay, so that is the function formula for the parabola that was graphed for me here in this problem. A real quick snapshot for part B. It's basically the exact same problem. Give you a different picture here. Just be sure that you are clear on which one of these coordinate points is the vertex and which one is the other point in the problem. I'll give you a minute to pause the screen there, and then we'll continue. Okay, so here in example 2, it's going to say in the directions, write the standard form of the equation of the parabola that has the indicated vertex and passes through the given point. So you'll notice now that I'm just going to go ahead and write out on the page what the coordinates of the vertex are and the coordinates of a point. And if you think about it real quick, this is basically literally the exact same question as our previous examples, except now I'm giving you your information in a different way. Instead of drawing the picture for you, I'm actually just blatantly writing down on the page the information that you need to solve the problem, and all you have to do is literally do exactly what we just talked about and go ahead and find the function formula like that. So let's go ahead and repeat that process here, right? So we want to go ahead and work with standard form, so that is y is equal to a times the quantity x minus h squared plus k. And then we're just going to go ahead and do the substitution of all these coordinate values here, right? So our vertex is going to be 4, -1. Keep in mind, this is what's playing the role of h and k. And then this other point that's on the parabola, that was our green point from before. That is going to be something that we can plug in as an input-output pair for x and y in this equation, okay? And so I'm just going to go ahead and do all those substitutions here in just one simple step, and then we're going to do some simplification and figure out what this value is going to be. So in place of y, we'll go 3. In place of x is going to go 2. And then in place of h is going to go 4, and in place of k is going to go -1. Okay, and so that means I can go ahead and write out the rest of this equation as 3 is equal to a times the quantity 2 minus 4 squared plus -1. Okay, and now I can just go ahead and do some simplification here and solve for that a value, which is the only unknown in this entire equation. And then once I have that a value, I can go ahead and write out the complete function formula. All right, so doing that mental math over on the right-hand side, I have 2 minus 4. That's going to make -2. And if I square that result, -2, I'm going to end up with positive 4 here. So this is going to be 4a, and then I have that plus -1 there. Remember, that changes to -1. And that is equal to 3. Okay, again, I've whittled this down to the point where this is now just a simple two-step equation. You can go ahead and do your simple inverse operations to isolate a in that equation, and what you would end up with here is basically, again, just 1. That's actually the same exact two-step equation that we saw in an earlier example before. Okay, and so a is going to be played by 1, which means I can go ahead and skip right to writing out the complete function formula here. That's going to be y is equal to 1, which again is just something I'm not going to write because it's just going to be a 1 in front 1 times. So y is equal to the quantity x minus 4 squared and then -1. That's going to complete our problem here. Okay, so really easy to do. Again, you're basically just on the lookout for that information, right? What is the vertex, and then what is another point on the parabola, so that you could plug those in for h, k, x, and y respectively, and then solve for a in that problem, and that's the function formula. Here's a quick snapshot of part B. Again, it's just the exact same problem. Here I'm showing the steps for how to do that two-step equation there at the end, but you should be ending up with the exact same result here. Again, plugging in that a value and then plugging in the coordinates of h and k. Very easy to do. All right, so here in example 3, you can see that we're going to solve this in a little bit of a different way because they're going to ask us for a different question. So reading the directions here really quickly, it says find two quadratic functions, one that opens upward and one that opens downward, whose graphs have the given x-intercepts. And then it gives us the note there that there could be many different answers that we have to solve this question, okay? You can see the work there for part B, which I'll go ahead and put back up here on the screen here in a little bit. But in order for us to go ahead and solve this problem, you'll notice that in part A, what I gave you are these two coordinate points here, okay? And so again, these are the x-intercepts of the graph. And so just to give you some better intuition for what it is we're actually talking about, I'd like to draw a picture, okay? Drawing a picture is not necessary to solve the problem, but I would like us to understand exactly what it is that we were given and what it is we're being asked to find, okay? So here I'm just going to draw a quick set of coordinate axes, and then the 2 points that I was given was negative 5, 0. I might just go ahead and plot that here, and then positive 5, 0. I might just go ahead and plot that right there, okay? So this is negative 5, 0, and this is positive 5, 0. Okay, so in the question, what they're asking for is they're asking you for the function formula for a parabola that's going to cross through these 2 points, one that opens up, the other that opens down. Okay, so if I were to draw the one that opens up and say blue, then that function may look a little bit like this. I'm going to kind of draw around that coordinate point there, and then loop that back around, and then continue to kind of go up just like that, okay? So a function formula for that blue one, we might call that maybe, say, f of x. And then we also want a function formula for a parabola that passes through these exact same two x-intercepts but opens down. So you could probably reason with me what that would have to look like. That would simply be the exact same x-intercepts there, but instead the parabola is just going to simply open down in this way, okay? And so we may give that a name. We might just simply call that g of x just to set it apart from f of x from before. But that's our goal, is we are trying to figure out what the function formulas for f and g, the blue and the red functions respectively, only having been given the x-intercepts in this way. Okay, so thinking about how we might solve that problem, what I'd like us to do is recall back from earlier in chapter 1, one of the videos that we talked about then. And it was actually your 1.4 day 1 video where we were solving quadratic equations by factoring, I believe, in that video. If you haven't caught that one in a while, maybe go back and give that one a watch. But this is one of the examples from the set of notes from that day. And the reason that I'm showing this to you is because I want you to realize that the answers that I've boxed here are basically just the x-intercepts, and I got that from the original function formula up there. Okay, so back then we were working in this direction, but now we would like to go ahead and work in the opposite direction to go from the x-intercepts up to the function formula in whatever form we choose, right? So just taking a quick look at how we did this problem back in the day, again, working in the top-down direction, we started off with the function equals 0, and then what we did is we factored it. Okay, so we factored it, and then we used zero product property to set each of those factors equal to 0. We were able to get these values for x, and of course, those corresponded to x-intercepts on our graph. Okay, in order for us to solve the problem that we currently have, we're going to have to work backwards. And basically what that's going to mean is we're going to start off with the x-intercepts. We're going to specifically take a look at those x-coordinates, and then this right here, we're going to be writing what the factorization would look like if these were the x-intercepts so that we could FOIL out that factorization and end up with our function formula. Okay, so let's go ahead and demonstrate that here, right? So if I've got negative 5, 0 and positive 5, 0, then what I'm first going to go ahead and write down are what those zeros would look like. Remember that these would be inputs that if I were to plug them into the function, it would result in an output of 0. And according to these x-intercepts, that would simply just be x is equal to negative 5 and x is equal to positive 5 from these two coordinate points that I was given here, okay? From these zeros, what I can do is I can go ahead and write some linear factors that I can use to FOIL out and figure out what my function formula originally was. So if I were to go ahead and write a factor that looks like x equals negative 5 would be the answer, then that would be x plus 5. And if I were to write out a linear factor that goes with this other one, x is equal to positive 5, then I would simply just go ahead and write x minus 5. So we remember from back in chapter 1 that we basically just take the opposite sign whenever we write that factorization out, okay? And then it would be at this point that we would just want to go ahead and proceed with our usual method for multiplying two binomials together, and that, of course, is our FOIL method that we've discussed in previous videos in class, right? And so I'm not going to demonstrate the FOIL method here because that would be something I would expect you to know, but just real quick, again, FOIL stands for F-O-I-L, first, outer, inner, last. It basically tells you what to multiply, and then you're just going to add all those terms together. So if we do that here, multiplying the first, x times x, that makes x squared. Multiplying the outers, that's x times negative 5, that makes negative 5x. Multiplying the inners, that's positive 5 times x, so that'll be plus 5x. And then multiplying the terms that come last, that's going to be positive 5 times negative 5, that's going to give you negative 25. Okay, and so that would be the 4 terms for the 4 letters in FOIL. And what I want you to now notice is that these terms in the middle here, negative 5x plus 5x, those would actually cancel out and make 0 for us. And so we're simply just going to be left here with x squared minus 25 as the function formula that we get, okay? And so that is actually going to be our f of x from before, okay? And so that is going to be our blue parabola that opens up. So I'm going to go ahead and write that down here. F of x is equal to x squared minus 25, and that is the exact equation of that blue parabola that opens up in my picture that has those two x-intercepts of negative 5, 0 and positive 5, 0. Okay, and so that kind of begs the question, well, what is the function formula for that that graph in red? What I might do here is I might just go ahead and do the exact same function formula, maybe instead call it g of x now, and just go ahead and distribute a negative inside of all the terms of f of x, okay? And so we'll go ahead and distribute a negative in, and then we'll get our final result here for g of x. That will look like g of x is equal to negative x squared plus 25. Okay, so we might remember from the previous video that if playing the role of a is a positive number, your parabola is going to be opening up. Okay, so like it is up here in your f of x. So I'll say that here. It opens up because playing the role of a is some sort of positive number. But down here below, in g of x, playing the role of a is a negative number, so that means that we're going to be opening down. Okay, and so that is when a is negative, okay? And so that would basically be the strategy or the method that you would want to use to go ahead and solve a problem like this. Given the intercepts, turn them into algebraic factors, FOIL them out, and get your final function formula, and then just distribute in a negative to get another version that opens down. Okay, here's a quick snapshot of the next example. We basically solve it in the exact same way. Here, it doesn't really matter that we were given the x-coordinate as a fraction. The work is the exact same as you can see. And just to kind of confirm that for you, I went ahead and I took my two results here for f of x and for what I should have called g of x. So let me go ahead and make that minor change here. Just because I don't want to give them the same name because they're different functions. So let's call that g of x. There we go. And I went ahead and I graphed them, okay? And so you can see here that these do cross the x-axis at the places that I was wanting, okay? So I crossed here at negative 5 over 2, 0. You can see how that kind of crosses in a half of a grid square. That accounts for the fraction. And then I also cross here at 2, 0, which are the two x-intercepts that I wanted, okay? And so that's going to do it here for this video. Again, I just wanted to go ahead and cover a couple of different additional exercises that you may be up against in your assignments and quizzes and tests. So thank you very much for your attention. That's all I have for this one. If you guys have any questions, let me know, but I will see you guys in the next one.